Okay, let's look at density problems. And so maybe even before this, the previous slide shows like density, typically the grams per cubic centimeter for solids, the grams per milliliter for liquids. So when we consider this example here, a 10 gram mass of sulfur is found to have a volume of 4.83 milliliters, calculate the density. You simply take the grams, right there, divided by the volume, right there. So grams divided by milliliters is grams per milliliter. This is the raw calculated output. 3 sig figs, 3 sig figs, 3 sig figs. Okay, so calculating density is pretty straightforward if you have the mass and the volume. So in terms of something like this, it's really just density of the cube with a volume of 475.98 cubic centimeters and a mass of 549.7 grams. It's just 549.7 grams divided by 475.98 cubic centimeters. 549.7 divided by 475.98 gives 1.154880457 grams per cubic centimeter. And then if you check your sig figs, 4 sig figs, 5 sig figs, you need a 4 sig fig answer. 1.155 grams per cubic centimeter. Right, there you go, rounded for correct sig figs. That's typically the areas where people, if there's an issue, it's typically that. In terms of this, what we can look at is sometimes we got trickiness where we got some conversion that has to happen. First of all, you need to divide mass divided by volume. So in this case, it doesn't really ask you what units it wants for density, but so it means you can reply in kilograms per cubic centimeter, but this is in cubic centimeters. So you need to take 4 times 7 times 10, 4 times 7 times 10, and that's 280 cubic centimeters. So now you can take your 8.56 kilograms divided by 280 centimeters cubed. 8.56 divided by 280, 0.030571429 kilograms per cubic centimeter. And it doesn't ask you for any units, so I guess you just go with whatever you're given, it's fine. So how many sig figs should it have? 1 sig fig, 1 sig fig, 1 sig fig, 3 sig figs. You need a round to one significant figure. And because this number is so small, you have to use scientific notation. 1, 2. Okay, 1 sig fig because of 1 sig fig up there. Right? So sometimes you got to do a little extra. Now, what we can also do is deal with things like this, where now it's asking for volume instead of density. So this is where unit analysis becomes important. So you have grams per cubic centimeter, and you have grams, and somehow you need to get a final unit of volume. You see cubic centimeters, so you need cubic centimeters. The way you're going to do this is you're going to have to do some creative rearrangements. So if you do this, you're going to get, if you literally times these units, if you take this unit times that unit, you're going to get grams squared per cubic centimeter. And that's not what you're being asked for. Somehow, we need to get cubic centimeters on top and grams on bottom so that grams can cancel. So what this is saying is that we have a mass of 937 grams and 3.75 grams per cubic centimeter. I'm going to flip the numbers upside down. So instead of saying 3.7 grams per cubic centimeter, and I'll put a little 1 right there because it's 3.7 grams per 1 cubic centimeter, I'm going to put the 1 cubic centimeter on top and the 3.75 grams on the bottom. So before we said 1 cubic centimeter is 3.75 grams. We're still saying 1 cubic centimeter is 3.75 grams. We've merely flipped the units upside down. Why? Because I want to be able to do this. Grams times centimeter cubed over grams equals centimeter cubed. Only possible when you take your density and flip it upside down, making sure to flip the numbers upside down so that 3.75 grams still says 3.75 grams. So, grams times cubic, okay, so here I'm going to set up the units. Next I'm going to plug in the numbers, 937 grams, 3.75 grams per cubic centimeter, so 3.75 grams per cubic centimeter. And now I actually do it on the calculator. So what am I going to type? 937 times 1 divided by 3.75. Well, timesing 1 doesn't do anything, so I'm just going to divide by 3.75. And I get 249.866 repeating. Cool. Grams cancel grams. Centimeters is the unit. That's how I know it's set up right. 3 sig figs. 3 sig figs, so I'm going to round, I need to make right here 3 sig figs, but that 9 is next to an 8, so it's going to be 250 with a decimal centimeters cubed. That makes it, because if you want to round right here, that means you got a 249, and this 9 has to round up because it's next to an 8, so that becomes 49 rounds up to 50. So 249 rounds up to 250. I put that decimal to keep it at 3 sig figs. Right, so if you look at another question, it works the exact same way. You need to take these and make sure they work. Now the thing is, look, grams, milligrams. Uh-oh. So you need to do 816 milligrams and convert it to grams. Let's see, you look it up on the chart, 1 gram is 1,000 milligrams, because milli means 1/1000. So 1,000, that goes next to the small number. And you do it on your calculator, 816 divided by 1,000 is 0.816 grams. So I'm going to take my grams and do something with this to get me the volume. So I'm going to take centimeters cubed per gram, flipping this upside down, times it by number of grams. That way grams cancel grams to give centimeters cubed, which is the volume that it's asking for. So 0.816. So 0.816 gram. Let's rewrite this more clearly. 0.816 grams, converted from the original milligrams, 2.87 grams per cubic centimeter, so there's your 2.87 grams per cubic centimeter, flipped upside down. So in this case, I'm going to take 1 over 2.87 times 0.816. And the answer, 0.28432 blah 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 cubic centimeters. Rounding for correct sig figs, 3 sig figs and 3 sig figs makes 0.284 centimeters cubed as my answer. Let's see. Supposing, by the way, what if I had changed this to make this cubic centimeters and asked you for the mass? What about this question? Well, actually, before the numbers, grams per cubic centimeter times cubic centimeter would equal grams, which is a mass. So that'd be great. You can just check your units, make sure they cancel, and you'll get the right units. That means you set it up right. So plug in the numbers. 3.75 grams per cubic centimeter times 937 cubic centimeters. So 3.75 times 937 equals 3,513.75 grams. 3 sig figs, 3,510 grams, or 3.51 times 10 to the third grams. 3 sig figs. So this is a way to, essentially we're taking units and canceling them so that we can get them to give an answer that we're looking for. In this case, applied to density. All right, so that should be an overview of what can be done with density.